slope field marks. There are some that suggest some important characteristics. Yeah, Papa Sam, what's one? An asymptote. An asymptote. That asymptote, if it was a population that it was modeling, would represent the what? The what of the population? The carrying capacity. So the carrying capacity in that logistic curve, in that logistic differential equation slope field, would be right about here, and it's labeled L. We like to label the carrying capacity, the cap, as L. There are some other important characteristics in that. What are some other ones? There's some other important things. Yeah, Tomas.
It's concave up.
Yeah, it's concave up, and then what is it? Yeah, it's concave up, and then what happens to it? Concave down. So what happens at that change right there? What's going on right there? dp dt is what? Greatest. There you go. It's the steepest one. It's the steepest one. And when does it occur? Yeah, you already figured out. When does that occur? Yeah, when P is equal to L over 2. It's half of the carrying capacity. When the population reaches half of the carrying capacity, it is growing at its fastest rate. And afterwards, it can still be growing, but it's slowing down. What happens if the population is greater than the carrying capacity? We're talking about this. We've talked about this, Wow, I talk good. It goes down, right, exactly. Populations tend to jump above and below and kind of oscillate. Why does that oscillation occur in real life? What happens? Like why aren't populations perfectly curved? Why do they bounce around? Yeah. Yeah, outside environments. Things can be added in. Exactly. Things can change. You know, a population gets eliminated by an outside influence or a new food source comes in, things like that. The carrying capacity could change, but generally what happens is it might move a little bit, population goes berserk, and it equalizes somewhere else. Yay, exciting. This is the general form of a logistic curve right here. This is what we haven't seen before. This right here is that general form. dp dt equals k times p times 1 minus p over L. That is the general form. You need to memorize that. You're going to work with it a bunch, but that is the general form. Super general, super helpful. The key is this. If I give you a differential equation, what have I asked you to do with differential equations before? Solve them. Yeah, solve a particular one for a particular starting value, right? But effectively integrate them, right? What was the first step that you hoped was possible if I asked you to integrate a differential? Yeah, you hope it's separable, right? What happens if it's not separable? Wah, 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 you are sad, you can't do it. Nah. Is this separable? It is. And here are those points we already labeled right there. Inflection point, maximum slope, L over 2, nice. Awesome. Okay, here's the thing though. Here's the thing. If it is separable, hey, it kind of looks like this. That's nice. We distributed. Okay, here's the real quiz question right here. What's the big thing that happens to go from here to here? What's that called? What did you do right there? To get from this line, we'll call it line 1 to line 2. What was done? It's written on the board. What did we use? We haven't integrated yet. Partial fractions. You see partial fractions right there, everybody? Remember partial fractions? So you have to use partial fractions. So the first thing that happened here was separation. Hey, the separation's pretty nice. Partial fractions, and now what can you do to get from here to here? What's going on right there? Just nice integration. Now you'll notice that something just gets dropped. What gets dropped? What's not, when you go to line 3, what's suddenly missing? What's not there anymore? L. L's gone. Can someone tell me why L is all of a sudden gone? It's a constant because you're integrating with respect to P and T, not L. L's a constant. It's in the same exact quantities on both sides, so what can happen? Cancels. You divide, multiply, whatever you want to call it, right? And now, can you isolate? Absolutely. Now, here's the thing. There are a lot of variables at this point. So what they do is they group them all together, or not all of them, some of them together, and give it another name. Remember how I said, like, e to a constant is just constant number 2. That kind of thing. So what's going on here is you keep this process up, and you end up with this right here. L is the carrying capacity, P is the population, K is part of that formula in that differential. If you wanted to isolate P, what does P equal? What does the population equal? L over what? Went too far down. Gave you the punchline. 1 plus AE to the negative KT. So that is your population right there, right? What is A? Well, A is just this. The carrying capacity minus P naught over P naught. So instead of writing that out, it's just a summary. Is everybody okay with that? Do you understand what I'm saying here? It looks really complicated. It's not. The idea is this. When you integrate, how many integrals can you get given a function? An infinite number. What do you need to narrow it down to one solution? You need a condition, an initial condition. In this case, you need P naught. Without P naught, you can't get A. You can't get your constant. So what does that mean? It means really this. You see all that work? Am I going to have you do that every single time you need to solve a logistic curve? No. What do you get to memorize? The blue box, everybody. You just get to use the blue box. I am not going to force you to do it by hand unless I say specifically, do this by hand. It's not something they ask you to do on the AP test as far as I remember. This is what you need to remember though, right there. You have to remember that along with A is equal to L minus P naught over P naught. If you remember these things, you are good to go. You are good to go. So what can you do with this? Well, you can find the general solution. The first thing you do to find the general solution is label all the pieces. Let's look at number 1 here. What's the K value? Yeah, that's the K value. What's the L value? 2800. So if you remember that formula, which I just showed you, you might have memorized it by now, maybe. Yeah, you're going to have P is equal to, what's on top? 2800 over 1 plus A to the negative 0.05 T. Now, does this give you an initial condition? No. So is that as far as you can go? Yeah, if you don't have an initial condition, you cannot go any further. Theoretically, you could have any condition and figure it out, but initial is what they're asking for. We don't know what P naught is, so we can't go any further. Okay, get to the board, everybody. Please get to the board. Find a partner. Find someone you know, really just want to work with. A little tiny trick that was mixed in. This one's pretty straightforward, right? Is it the right form? Yeah, it's the right form. So your carrying capacity is 5,700, right? And what is your K value? Is the K value? We were graphing trig functions earlier, so I get messed up with all the variables. I'm sorry. What's the challenge here? You just need to know what that is. What is that? That's P over what? It's 4,000, right? So in this case, L is 4,000. It's relatively straightforward. Relatively straightforward. They will trip you up. Like this right here could have come from central casting from the BC calculus exam. Like, it happens. That's about as tricky as it gets. You just have to remember the form. Because you really just have to memorize what? This right here. Okay, so let's change it up just a little bit here. I'll leave the formulas on the board for you. Right here, I'll leave the formulas up on the board. And, yeah, do this one by yourself right here. And I'll unfreeze it. I'll unfreeze it when I paste it in there. Hold on one sec. First on this one. Factor, right? So you're going to want to get what? dp dt is equal to, what do you factor out? Oh, it's still frozen. That's 10 what? 10 what? 10p. You want to factor out 10p, right? So you get 1 minus what? P over 2? Like that? Oh, that automatically tells you k is equal to 10 and L is equal to 2. Nice. Yeah, so you can now find A in this. You know that A is equal to L minus P naught over P naught. So what does that equal to? A just comes out to be what? I think 3. Does A come out to be 3? So what do you end up with? P of T is equal to 2 over what? Plus negative 10T. Done. Awesome. So you have your what? No, it's just 3. Because when you plug in, the L cancels, you end up with L3, yeah. So there is a second part to this. What is it? And the time to the peak value of dp dt? How do you figure that out? What do you have to set it equal to? L over 2. The fastest dp dt gets, the largest it gets, is when the population is half the carrying capacity. Well, we know what L is, right? What is that? So it's just what? So you're solving 2 over 1 plus 3e to the negative 10t equals 1. Is that something you should be able to solve? No? No? What was that? Pleative? No. Come on. Yeah. So what do you end up with? 2 equals 1 plus 3e to the negative 10t. Yeah. Yeah. Then what? 10t is equal to what? So ln of? So t is equal to? And you can make this even cleaner if you wanted to, because 1/3 is 3 is a negative 1, right? So you end up with t is equal to negative ln of 3 over negative 10. So if you really want to make it clean, because the AP test will do this to you, unfortunately, t is equal to ln 3 over 10. It will do that to you. Just showing you what it will do. It likes to get negatives out of there. You'll notice that in this formula up here, what do they give you? They're like, what do they say? Like, the maximum rate of change happens at 1 over this, right? You can memorize that if you want to. Just solve. Set it equal to L over 2. I like remembering that it's L over 2 because it forces you to remember that dp dt will be maximized when the population hits L over 2. Kind of nice. That's okay.